The distributive property says that if you have a times b plus c, then you can do a times b plus a times c. Let's first prove that 3 times 10 plus 2 is equal to 3 times 10 plus 3 times 2. If you have 3 times 10 plus 2, then you have 10 plus 2 plus 10 plus 2 plus 10 plus 2. Then you can put all the 10s at the front and all the 2's at the end. But 10 plus 10 plus 10 is 3 times 10. And 2 plus 2 plus 2 is 3 times 2. So as long as the number on the left is something like 1, 2, 3, blah, 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 this process is the same thing. So if you have a times b plus c, then you have b plus c plus b plus c plus blah, 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 b plus c. How many times? A times. But we can put all the b's at the front and all the c's at the end. And since we have a b's, then we have a times b. And since we have a c's, then we have a times c. So that's a really simple proof, but it only works if a is a number like 1, 2, 3, blah, blah, blah. We still have to prove that it works for negative numbers, 0, fractions, and also irrational numbers, but we won't do that in this video. To prove it when a is equal to 0 is easy. You just go to the main rule and plug in 0 wherever you see a. And if you don't end up getting 0 is equal to 0, then you're Next, we'll prove the rule works when a is a negative integer. So negative 1, negative 2, negative 3, blah fucking blah. So our goal is to prove that even in this case, a times b plus c is equal to ab plus ac. We want a to be the negative of a counting number, so let's let a equal negative n, where n is a counting number. So then our goal becomes not to prove a times b plus c is equal to ab plus ac, but to prove negative n times b plus c is equal to negative n times b plus negative n times c. And we're about to do some tricky shit. Line 1 says n times b plus c plus negative n times b plus c is equal to 0. That's just the additive identity, like 4 plus negative 4 is equal to 0. Then, since n is a counting number, and we know the distributive property works for counting numbers, we can change n times b plus c into nb plus nc. But we also know that nb plus negative nb is 0, and nc plus negative nc is 0. So the sum is 0. Since both line 2 and line 3 are equal to 0, we could set line 2 equal to line 3. Then we can cancel nb plus nc in each of them. And we're left with what we're trying to prove. And then some real wacky shit happens if a is a fraction. So to be general, we'll call our fraction r over s, where both r and s are integers. Because any fraction is made up of an integer on the top and an integer on the bottom. So now our goal becomes not a times b plus c is equal to a times b plus a times c, but r over s times b plus c is equal to r over s times b plus r over s times c. Well, I started by putting b plus c over 1. And then I multiplied the two tops of the fractions and put it on the top, and the two bottoms of the fractions and put it on the bottom. And then we use what we just proved, the distributive property of integers. Because r is an integer, so we can change r times b plus c into rb plus rc. And then if we were to add the two fractions in line 4, we would get the fraction in line 3. So line 3 must be equal to line 4, so we can change line 3 into line 4. In other words, substitute. And then to get to line 5, we use the same reasoning, but this time about multiplying fractions. And that's it! We did it! Well, not quite. We only did it for rational numbers. So it still leaves irrational numbers like pi and square root of 2. I don't know how to do it. If anybody knows a good way, let me know. But in the meantime, I gotta play Halo!